Notice, and this is typical copyright, we continue with mathematics syllabus 2018. We are now at section 8, geometry and trigonometry, and this is the second of 24 videos from this section. Returning to section 1, some of these videos are even applicable in primary schools for students who could look at the videos on their own, for teachers who may use some of these videos in the inverted classroom, and especially by parents who want to help their children but do not think that they have the capability or the ability to do that. For example, if we expand this blue box here, you will notice video 6, it says add, subtract, multiply, and divide whole numbers. This is work that is done in grade 3 of the primary school. And then video 7, add, subtract, multiply, and divide decimals, grade 4 work. Video 8, add, subtract, multiply, and divide fractions, that's video 8 and 9. Also done in primary schools, grades 5 and 6, and so on. So these videos that are part of the CXC syllabus, math syllabus, begins with work that is done in primary school in grade 3. Section 6, algebra, which seems to be a problem area for most learners. 7 of these videos have been published on YouTube in their entirety, the others partially. Again, please see directions in the description below if you need full access to these videos that are only partially published on YouTube. Objective 1, Part A, and it has been published in its entirety on YouTube. We are now at 1, Part B. When that is finished, it will be published partially. So Objective 8_1 says explain concepts relating to geometry. And then there are lots of concepts listed here. We already did some of them in the last video, which was Part A of this objective. Now we are dealing with this last part. So those were completed in the last video. Now we have to deal with this down here. Completed video 1A. Now we have to deal with these generally four concepts. So let's begin with, for regular solids, what do we mean by faces, edges, and vertices? And we will be looking at 2 of those solids. They are prisms, triangular prisms and rectangular prisms. And then after that, we will go on to the next section. But remember, all of these are done in this one video. So let's talk about faces, edges, and vertices. We will begin with a rectangular prism, which looks something like this, like a box. This is a transparent version. What do we mean by faces? The sides of the shape or the solid, the sides. For example, you will notice a side here to the left. That is a face. And you may be able to see that there are 6 faces there. What do we mean by edges? Where the faces meet. For example, you may see that that top face meets this front face here along BC. That line. That would be an edge. And of course, this here will be another edge. BF, where 2 faces meet. And vertices are where the edges meet. As you could see down here at F, you have 3 edges meet there. This one, and that one. And of course, at A here, you also have 3 edges meeting at that point, and that point A will be called a vertex. Let's look at a triangular prism. This is the transparent version. Faces are the sides of the shape. So you could see a near face here, which is a triangle. There is also a corresponding one in the back over there, and 3 along the length. Edges are where the faces meet. So you could see this triangle in the front here. It meets that face along AC. So AC would be one of the edges. And there are quite a lot of others. So that would be edge. And then vertices are where the edges meet. So you could see up here at A, that edge meets this edge, which meets that edge at A. That is one vertex. Down here at C is another vertex. So you have 6 vertices where the edges meet. So those are prisms. Now we are going to deal with pyramids. This is what a pyramid looks like. The first thing you will notice is that unlike the prism, it has only one rectangle below here. But the same thing applies. What do we mean by faces? The sides of the shape. The sides. So you could see a side in the front here. What do we mean by edges? Where the faces meet. So you could see that front face there meets this side face here along this line EB. This here. So that's one edge. And vertices where the edges meet. Most obvious one here is A. You would notice the edge coming on from the top there, and this edge going like that, and that one coming from the back there. They all meet here. And then of course there is another one here, and so on. So vertices are where the edges meet. If we do the same thing for a triangular pyramid, so you have a triangle underneath here, that's the base, and you have 3 sides that are triangular, and they all are slanted and they meet at this point up here. So faces, again, the sides of the shape, as in this case here. Edges, where the faces meet. And by now you know this front face here meets that one there along the line SR. That is one edge. And then vertices where the edges meet. So you could see P here is a vertex. You have 3 edges meeting there. Q here is another one, and so on. And so is R down here. So now we will deal with specific shapes, not just general shapes. We will deal with faces, edges, and vertices of regular solids. Before we do that, let's make sure we know the difference between prisms and pyramids. What you see here is a prism. This one on the right is a rectangle, well actually it's a cuboid, and what you see on the left here is a triangular prism. What do we know about them? Well, they have 2 end faces that are identical. That's the first thing you know about a prism. And of course, those end faces give the prism their name. So this one is a triangular prism, and this one here is a rectangular prism. That's the first thing. 2 such faces opposite each other. And next, the edges of one end face are joined by rectangles. So note the edge of this triangle and the edge of that triangle, they are joined by rectangles along the side. And note the edge of this front face here, and the edge of that back face there, they are joined by this rectangular shape here. All the shapes are rectangular when they join the front face to the back face. Now, a cylinder is considered a special type of prism. They have two end faces that are identical, and they are joined by a rectangular, though curved, side face. So what are pyramids? Pyramids have only one end face from which they get their name. And the side faces are all triangular, and they slant to meet a point at the top called the apex. Triangular side faces slant to meet a point. So here you have a rectangular pyramid. As you could see, it has one end face down below there. It has some slanted faces that are all triangles, and they meet at the point on the top here. This is a triangular pyramid. It has a triangle at the base, and then the sides are also triangles, and they all meet at the point on the top here, which is the apex. You may be familiar with pictures of the pyramids of Egypt, like you see here, that type of shape. And a cone is also considered a special type of pyramid. Notice it has a shape down here, and the side slants upward to a point on the top there. Just to reinforce that concept and to make sure we understand the difference between prisms and pyramids, we will consider these two examples. This is a square prism, which is a cuboid, and this is a square pyramid. You have a square under here and a pyramid. We will come back to this. This is a triangular prism, and this is a triangular pyramid. So in the case of prisms, there are two identical end faces. This is a triangle here, that's a triangle here. And these two end faces are joined by rectangular side faces. That's a prism, a triangular prism, because the end face is a triangle. This is a pyramid, a triangular pyramid. You only have one triangle at the end. The other end is a point. So this is a triangle from which it gets its name, triangular pyramid. In the case of a pyramid, you have only one of these shapes, and the side faces are actually slanted triangles that meet at a point here called the apex. Prism, pyramid. Now this is a rectangular prism. The rectangle is a square, so it's called a cuboid. Notice you have the square on this side and the square on this side, and those two end faces are joined by rectangular sides. Two identical side faces joined by rectangular sides. That is a prism. This is a pyramid. You only have one rectangle down here. Rest it like that. The side faces are slanted triangles that all meet at the top here. Pyramid, prism. A cylinder is considered a special type of prism, and a cone is considered a special type of pyramid. So now let's deal with triangular prism. We are going to deal with specific shapes now, dealing with faces, edges, and vertices. So this is a triangular prism. Let's look at the transparent version. How many faces does it have? As you could see, you have a front face here and a back face there, the two end faces, plus the side faces that join the front face to the back face. So you have 2, that's the end, plus, because it's a triangle, you will have 3 along the side. So 5 faces. How many edges does it have? Well, the first triangle here has 3. The one on the back there has 3. And you also have 3 joining the front face to the back face. So you have 2 times 3, that would be the end edges, plus 3 more along the length, and that will be 9. Now, it is 3 because we are dealing with a triangle at the end. And how many vertices does it have? Well, all we need to deal with would be the end faces, because the side edges do meet at the end. So you have 2 end faces, and since they are triangles, then you would have 2 times 3, and you would have 6 vertices. Now, what we just described there, we can work out for any other prism. So this is the one for a triangular prism. Now let's see that as a paper model. So now let's look at faces, edges, and vertices. In the case of a triangular prism, you have the 2 triangles on the end. That will be 2 faces. You have the 3 faces along the side. That will be 3 more faces. So this triangular prism has 5 faces. How many edges does it have? This end triangle here has 3 edges. This one over here has 3 edges. And then you have these edges here, 1, 2, 3 more edges. So this has 9 edges. How many vertices does it have? Well, since a vertex is defined as a point where edges meet, that edge meets this edge and that edge at this point. So that's 1 vertex. There is another one over here and another one over here. That's 3. And over on this side, there is 1 vertex here, 1 there, and 1 there. So that's 3 vertices. A triangular prism. 5 faces, 9 edges, and 6 vertices. Now let's deal with a cube. A cube is a special type of prism. Cube, cuboid, and rectangular prism, they basically follow the same pattern. So a cube looks like this. All sides are equal. This is the transparent version. How many faces does it have? Well, if you consider this end here as one end face and that one on the other side there, then it would be those 2 faces plus the other 4 that connect the end faces. So it's 2 plus 4, and that would give us 6. And the reason this is 4 is because we are dealing with a rectangle here. To be specific, a square. How many edges does it have? Well, the front face here has 4. It is a special type of rectangle. The back face there has another 4. And then to the side, joining the front face to the back face, you have 4 more because it is a rectangle. So you have 2 times 4, that would be the end faces, plus 4 would be the side faces there. So that would be 12 edges. How many vertices? Well, we can ignore the edges along the length and just deal with the front and the back face. Since there is a special type of rectangle here, actually is a square, we will have 4 vertices in the front and 4 in the back there. So that will be 2 times 4, and that would give us 8 vertices for a cube. It's a special type of prism. It's more like a square prism. Let's see that as a paper model. Now we will look at a cuboid. Now imagine you have a cube like this. Imagine you have a cube like that and you stretch out that end like this. So you get something like this. So this end is still a square, but now you have rectangles along the length. That is called a cuboid, meaning cube-like. That is called a cuboid, meaning cube-like. So how many faces? Well, the same thing that applies to a cube would also apply to this size of a shape. We have the 2 ends, which will give us 2, and then along the length here, 4 more. So 2 plus 4, 6 faces. How many edges? Same principle. This square here to the left will have 4. That one there, another 4. And along the length, another 4. So if you multiply 2 by 4, that will be the 2 end faces with 8 edges and 4 more edges connecting those 2 faces, which will give us 12. How many vertices? All we need to deal with is the end faces. Since it is a square, then each end face will have 4. We have 2 such end faces. So it will be 2 times 4, which would give us 8 vertices. Let's see that as a paper model. Now let's consider a rectangular prism. Now consider that cube that we just looked at. And then if we stretch that cube out this way, we will get a cuboid like that. So that was a cuboid. Let's extend it this way. And now if we take that cuboid and stretch it out this way towards us, we will distort this square here. And now we have a regular rectangular prism. All the faces are rectangles. As we can see here, faces, same thing that applies to the previous 2 that we just did, the cube and the cuboid. 2 plus 4 should be 6. Edges, same thing for the cube and the cuboid, which would be 2 times 4, that would be the 2 end faces, plus 4 more along the side, 12. Vertices, we just deal with the end faces. This rectangle here to the end has 4. That rectangle to the other end there has 4 more. So that will be 2 times 4, which would give us 8 vertices. Let's see that as a paper model. This is a cube. All the sides are the same measurement. If we consider this and this as end faces, then you have those 2 end faces plus the 4 along the side here. That would be 6 faces for a cube. How many edges? Well, along this square end, you have 4 edges. Along this square end, you have 4 more edges. And along the sides, you have 4 more edges. 1, 2, 3, 4. So that would be 12 edges. How many vertices? Remember, a vertex is the point where edges meet. So you have that edge meets this edge and this edge. at that point, that's one vertex. Another one over here, that's 2. One over here, 3. One over here, 4. And over on this side, 1, 2, 3, 4. So that would be 8 vertices. So 6 faces, 12 edges, and 8 vertices. If you were to take that cube, so the end faces, these are the end faces, and you were to stretch it out like that, this end will still remain a square. But then the side faces will now become rectangles. Now this is called a cuboid, meaning cube-like. It still retains one, the end faces are still squares, but the side faces are now rectangles, as opposed to this one, where all faces are squares. So whatever we did for this one in terms of faces, edges, and vertices, the same applies to the cuboid. 1, 2 end faces plus the 4 to the side. That would be 6 faces. Edges, you have 4 here on that end face. You have 4 more here on that end face. And along the side, you have 4 more. So that would be 12 edges. And in terms of vertices, you have 1, 2, 3, 4 along this end face, and 1, 2, 3, 4 more along this end face. So that will now give us 8 vertices.